surface area. And when we looked at surface area yesterday, we looked at creating nets and then transferring the measurements from our three-dimensional shape to the net. Today we're going to be drawing three-dimensional shapes and finding the surface area without a net. Let's first start by drawing a rectangle. The size of your rectangle doesn't really matter. And then what you're going to do is draw a rectangle the same size, but a little bit to the up and right, like that. Then you're going to connect your corresponding angles. I heard you did this in art class, is that true? I like drawing three-dimensional shapes. So let's say that's 4, let's make that 2, and let's make that 8. And let's say that we're dealing in inches. The measurement doesn't really matter, but we'll need it at the end. Now, if I'm not finding a net for this, I could draw a net, but oftentimes it takes a little bit extra time, and we are sometimes in a hurry, and the net is not crucial for every problem. I'm just going to identify all of the different sides that I need to find. For example, the front of this and the back of this. Those are 2 of the sides that we'll need to find. We'll need to find the top of our figure and the bottom of the figure. So that's another group, top and bottom. And then the left side and the right side, so each side of our figure. Now this is where we will be using our colors. Let's start with the front of our figure. So if I'm looking for the front of this figure, what will be the area of the front of that? Alexis? Because the area is length times width, it is 4 by 2, so the area of that is 8. If our front is 8, what does our back have to be? Has to be the exact same. The front and the back are corresponding, so they have to match. Let's look at the top of our figure. I'm going to highlight the top of our figure now. What is going to be the area of the top of our figure? Natalia? And how'd you get that? Yeah, it'll be 8 times 2. Because that length right there is 2, that length right there is 8. So you are correct. And if the top is 16, then the bottom also has to be 16. And then the last one that we're going to find are the sides. That's this side right here. What is the area of that side going to be? Nathan? 32, very good. The length of that is 8, and the height is 4. Tells us that right there. So we're going to do 4 times 8. And if our left side is 32, our right side also has to be 32. So those are matching. Now, all I got to do is add them together. I'm going to do 8 plus 8 plus 16 plus 16 plus 32 plus 32. So altogether, our surface area is 112, and we did say it was inches, and area is always squared. So the surface area is 112 inches squared. Notice what I did was I added them all up. But there are other ways to think about that. If I do the front times 2, that'll give me the surface area of the front and back. 16 times 2 gives me the area of the top and bottom. 32 times 2 gives me the area of my sides. So there's different ways to think about that. Let's look at a, yes?
Is the pattern anything with the 16 times 6?
No, it's just the numbers that I chose are.
Yeah. Never mind.
Yeah. Yeah, you'll see that in the next. I want to choose friendlier numbers, but yeah, no, that's a good pattern to notice. 8, 16, 32, and then we go 2, 4, 8. So yeah, there is a pattern there. There's a pattern in our next one also. Let's make a triangle. Let's go 3 by 4. That's what mine is. It's a right triangle, 3 by 4. And then make another one over here, same size. And I'm going to connect all the corresponding pieces. It's okay if yours doesn't look great. Mine does because I'm amazing. So, you know, that's just me personally. I'm really good. I say that now, but my cylinder's going to be awful. I find a way every time to mess that up. Now this, I'm going to put the dimensions on here. So I said that was going to be 3 by 4, and then this length here, let's say the height of this is, let's say 6. And then the length of this side right here is going to be 5. I'll just mark it on this side over here. And let's do feet this time. That's shorthand for feet. So I've got 2 triangles. I've got a front and a back for my triangles. The front and the back are going to match. Those are going to be the same measurements. But my sides are going to be different. Remember that we said what we said about the belt that goes around the middle? This one had 1, 2, 3, 4 pieces for the belt. So there was those 1, 2, 3, 4 pieces for the belt. This one has the one in the back, one on the front here, and then the one on the bottom. There's 3 pieces. This one is going to be 3 by 6. This one's going to be 4 by 6. And this long one here in the front is going to be 5 by 6. So they're all going to be different sizes. So I'm going to mark those as kind of independent. The first one that I want to look at, let's look at the triangles. So the front and the back is that triangle right there. The base of that triangle is 4, the height is 3. What's going to be the area of that triangle? Doward, what's it going to be? Looking at the triangle.
6.
Yeah, it's going to be 6. It's 1/2 times base times height. 1/2 of 4 is 2. 2 times the height will give us 6. If our front is 6, that means the back has to be 6 also. Now let's look at the different sides. Let's start with that one right there. That side right there. What's the area of that side going to be, Scout?
18.
Because it is 6 by 3, so that'll be 18. And then we can do this bottom side over here. That one right there. What's the bottom of that figure going to be, Tyler?
24.
24, good. It's 6 by 4. And then we've got this front one. I'm just going to shade it in with my pencil. So we got the front here. And what's the area of that one going to be? Ryan? This front piece right here? 30? Yep, 5 by 6, so our area there is 30. And for this one, add up all the sides. We're going to do 6 plus 6 plus 18 plus 24 plus 30. So the area of our figure is 84 feet squared. That's our surface area. All right, we got one more that we're going to look at. Our cylinder. I'm going to start with an oval. Like that. I'm going to draw straight down. Put that around. That's not too bad. I've drawn worse. So let's say the radius of that circle is going to be 4 meters. And the height of this, let's say, is 7 meters. Looks a little off, but it'll work. So in this figure right here, I've got a top and a bottom. The nice thing about top and the bottom, front and the back, basically it's just the circles. We'll call it top and bottom, just for simplicity. The nice thing about a cylinder is you really only have to find 3 measures. And 2 of them are going to be the same. You got the top and the bottom. The hard part is the side, that belt that wraps around. That's really going to be the hardest part. Let's start by finding the area of that circle. So we have to use the formula for a circle. What is the area of that circle going to be? Lena? So it would be pi times our radius, which is 4 squared, which gives us 50.26. I'm just going to round it to 50.3. So the top is going to be 50.3. If the top is 50.3, the bottom also has to be 50.3. Now we have to find the side. The side's the hard part. In order to figure out the length of that side, we have to find the circumference of that circle and multiply it by how tall that is. To find the circumference of the circle, I'm going to do the diameter, which is 8, times pi. So the diameter is 8. 8 times pi, or pi times 8. And then I have to multiply the diameter times how tall that figure is. Multiply that by 7. And when you do that, you get 175.9. I would round it up to 176. And then you can just add those 3 together. So you'll do 50.3 plus 50.3 plus 176. So the area of that figure, the surface area, is going to be 276.6 meters squared. Do you think it's easier to do it this way or to draw a net? This way tends to be quicker. It's a little bit more efficient. It's a little bit easier to make mistakes. But it is a little bit more efficient. If you ever get kind of distracted or need to double check, using a net is definitely useful.